I'm Gavin from Spitfire Engineering, and this is episode 10. So in last week's episode, I told you about some sight boxes that we're building for a customer. I lied to you. Sorry about that, but I did lie to you. It's not 4, it's 5. And this is one of them that's finished by the looks of it. So this is the box. This is on its side at the minute. This will stand up, and then the lids sit on top of this. So this one's finished, and in the workshop, they're still welding some of them up. So we've got 2 boxes being welded up here. Connor's inside this one, welding up at the minute. So we've got these being welded up. There's another 2 still to do. So we'll get the GoPro going and show you Connor welding these up. So I showed you last week these frames that Steph's been making to go on the oil screen. We've got one on, that's the second one to go on. That's the second one to go on, and Steph's already got the first one on. So Steph's already got this one in place. This is where it's going to sit, and sitting on top of that will be the screen box. So the screen box will sit on there. And then, as I said the other day in that, we've got a distribution hopper that sits above the screen, which when we get to, we'll show you that. So that frame's going on there, and the other frame is going to go on here. So the other screen box will come on here. So the operators, they'll come up the steps, and they'll come around and do all their maintenance on the walkway. They'll be able to change the screen meshes from the walkway nice and safely, both ends, because unlike our E21, this is basically the same box as our E21s, but instead of the meshes coming out the bottom of the decks, these ones are going to come out the top of the decks. So we've done the walkway so they can change the meshes really easy without having to climb on things, all nice and safe. So that's where we've got to on this. Let's go and have a look and see what else they're doing. So we've got the 2 big conveyors that are going to France, pretty much built up now. The belt people are booked to come a week today. Next Monday they're coming, and they're going to come and put the belts on these 2 conveyors, as well as the 2 smaller conveyors. Now Rob's still putting together the 3rd conveyor, so that's going there. And the other one is due to be painted today and start being assembled this week. Now, as you know, we've got issues with assembly space, which we are trying to work on at the minute, which is while we're outside just putting these together, because they're so big, they take up so much space in the workshop. But luckily the sun's shining, so it's actually quite nice today to do them out here. So on these conveyors, these are all pretty much done now, ready for the belt. We've still got the head and tail drums to put in. We've got all the rollers in, everything's put together, and then once the belt's in, if you remember, we were doing side skirts that went over the sides here, that we did the curved pieces in previous episodes. If you remember, that's what we were doing. They will go on after the belt has been fitted. So next job is to get the head and tail drums fitted on these, get the gearbox fitted as well, because that will aid assembly on the belt. And then once that's done, we'll put the side skirts on and do our final checks, run up, final checks, and then these are pretty much ready to go then. So we've got these 2 big ones here, the small one over there, and the other small ones come in. Should all be put together this week, ready for the belt people next Monday. So I'm back in the yard this morning, and I thought it'd be a good idea to show you some of the welding processes that we do here. Now this is an opportunity for the people that don't know a lot about welding to buff up on your knowledge, and it's also an opportunity for the people that do know a bit about welding to put in the comments where I've gone wrong and the bits that I'm not telling exactly how it is on there. So this is an opportunity for all the expert welders to tell me where I'm wrong. So I'm going to tell you about the 3 different welding processes that we do here at Spitfire. Mostly what we do here is MIG welding. If you look at a previous episode, last week's episode, I was up at D&J Projects and I was stick welding. Now, Connor here is doing some TIG welding because he's welding up the stainless steel tanks and the distributors that we're doing for the deck screens for the oil company up at Birmingham. So we TIG weld aluminium because it's a different material to mild steel. Technically, you could do it with a MIG welder, but it's not the best weld. It's a corrosive weld. It'll be corrosive, the weld itself, where you'd probably use stainless in an application where you didn't want it to corrode and it could be kept relatively clean. A lot of food grade stuff, anything that's in the food industry is done with stainless because it's clean. So on this application, the customer has specified that we do the tanks and the distributors at the top of the deck screens out of stainless so that there's no corrosion, everything flows nice, and they can clean it out at the end. So for that process, we use what's called a TIG welder. And Connor's been doing some TIG welding, like I say, so I'm going to show you what that actually means. So this is the TIG welder that we use in the workshop. We don't do a huge amount of TIG welding. It's a rare occasion that we do any TIG welding. We use this machine mainly for stainless or some aluminium. I've got the facility to MIG weld aluminium, but when it comes to stainless, we sort of have to use the TIG. So the TIG torch, I'll just run you through what the TIG torch involves and talk through the process of what's involved when it comes to TIG welding. So this is the TIG torch, and basically what you've got, this is obviously handheld by the welder, and we've got a button on the back, which is this button here, that just energises the welder. And what we're doing is, if you look in there, that tip in there, that what looks like a pencil coming out the middle, that's called a tungsten. And that's sharpened to a point, because you need to sharpen that to the point to create a nice arc that you can weld with. The pinky looking cup that you see around the outside is called the shroud. It is a shroud on it's still a shroud on a TIG welder, isn't it? So I've got Connor here who's doing the TIG welding, and he probably knows more about TIG welding than I do, to be honest, so he's going to shake his head in the background or nod if I'm saying the right or wrong things. So the shroud itself, because we use gas and we use an argon gas, pure argon in this, Connor? Yeah, Connor's shaking his head, so it's definitely pure argon. So we use pure argon in this, where on the MIG welders, we use a different gas. This is what we use is pure argon, and when you press the button, it releases the gas, and the gas comes out inside that pink shroud, and what it does, it encases the weld pool in argon, and what we're doing is we're stopping any impurities getting into it, anything like the air that we breathe in the atmosphere. If we didn't use an argon gas, all the oxygen and all the other gases in the atmosphere would fuse into the weld, and it would create a porous weld. Am I telling right? Connor's still shaking his head, so I am telling right. So, and you would end up with porosity in your weld. If you actually did it and actually looked at it, if you can think of like an aero chocolate bar with all the little bubbles in it, that's what it would look like. So we use the gas to create a shield around the weld, so none of the atmospheric atmospheric impurities can get into the weld. And what we do is we use a filler wire, which is one of these. So it's a really thin wire, and it's a two-handed operation. So you hold the torch in one hand, and you hold that point on the tungsten close to where you're welding. You press the button, and basically with any welding process, or most welding processes, not all of them, there's different welding processes, but most of them, what you're doing is you're creating a concentrated heat through an arc process. So it's where the electricity jumps from one metal to another and creates an arc. It creates intense heat and basically melts the metal and fuses it together in its most basic form. And you can see some of Connor's welding on here, and that is TIG welding. So you hold the torch in one hand and you have the filler wire in the other, and you're feeding the filler wire into the weld pool to create the weld. So we're going to get some footage now of the weld process and you can see how it works. So you'll notice as Connor's welding it, he's actually dabbing the filler wire into it. So the torch creates the arc because the workpiece is earthed, and he's dabbing the filler wire into the weld pool, and as it's melting, you'll see the finished weld. So the electrical current, as I say, is generated obviously by the welder, and the arc is the electricity basically jumping the gap between the tungsten in the torch and the earth piece. And we obviously have to connect the welding machine as the earth, and this lead here on our TIG welder is the earth, and that runs back into the welder. So basically what you're doing, if you think of it, if you've got a car battery and you put a wire between the negative and the positive, as soon as you got near to the other terminal, you'd end up with a spark. And that's very similar to what's going on in the welding process. And that spark, that arc, is what generates the heat. But obviously we need to then create the circuit by having an earth on here. The material that Connor is welding is obviously metallic. Even though it's stainless, it's still a metallic metal, it's still a metallic material. And that is sitting on the bench. We earth the bench. So any piece of metal that we put on the bench is technically earthed to the welding machine. And it's, as I say, it's the current jumping between the two that creates the arc. Now, any welder will tell you and guarantee, they've all done it, forget to put this earth lead on, and as soon as you go to strike an arc, nothing happens, and it's purely because the earth lead is not attached. So that gives you the real basics of TIG welding. A lot of the welding processes probably follow the same principle. An arc with a degree of filler wire. Arc welding is the same, MIG welding is the same, TIG welding is the same. You're creating an arc to generate the heat, to melt the material, and then you add another material, a filler wire, into the molten metal that it's created by the arc, and that is in basic form the welding process. As I say, I'm sure there's expert welders out there that will probably correct me in the comments, all the bits that I've got wrong or missed out, so fill your boots. But in essence, that is TIG welding. Not everything at Spitfire goes perfectly. We are not perfect, and this handrail here and platform was made, went into the paint booth, and they lifted it up to move it, and this was upside down at the time, and as they lifted it up, this handrail here got caught underneath the forklift mast and got bent, which is a bit frustrating, but luckily it's not too bad a job. So that's been cut out, and he's currently having a new piece welded in there. And we'll be back to original. It just shows things do go wrong, and if that's the worst thing that happens this week, we've probably had a good week. So we're just going to lift this in now. We've got the suspension units mounted to the deck. So what we're trying to achieve here is to make sure that all the holes line up. No reason why they shouldn't, but when you're doing bespoke stuff like we do, there's no jig for this. It's literally done by skill and measurement from the fabricators. So it's always a good idea to just double check to make sure that everything is as it should be. So we've got these plates on here, one there, one there, same this side. And what we're going to do is just make sure that all them holes line up. Connor's just bringing in the tank that's going to go underneath. We're going to stick that in first, by the looks of it, just to see how the fit-up's going to be lining everything up. Got to be lowered in the top? Okay, it looks like we're going to have to lower the tank in the top because it won't fit through that gap. Okay, slight change of plan then. We're going to have to lower it in the top. So we're just lifting the tank in now. We're going to have a problem in a minute because the straps aren't long enough to lower it in place. So what we've had to do is put 2 bits of box section across. So we're going to lift the tank in and put it on them 2 bits of box section. And then we're going to have to pick it up underneath and lower it down because that tank is eventually coming down and sitting on those 2 beams there and some holes there. Now you've probably heard me talk about the belt that we've ordered for these 4 conveyors that are going to go to France, and 2 of the belts have just been delivered. So let me flip the camera around and I'll show you what I've been talking about and you can see the makeup of the belt. So this is the belt here. I've been talking about a flexible sidewall, and it's this. This is made from rubber. It's bonded to the belt, and when it goes around the head and tail pulley, it will open up and flex, but it remains a rigid sidewall. So the material is obviously going to land in this middle area. These cleats here are going to hold the material in place on the belt as it goes up the incline, but we don't want the material to fall off the edge of the belts in this application. So we've got flexible sidewalls here to contain the material in the centre of the belt. Now this belt also, I'll show you the side profile of the belt. This is actual puncture-proof belt. It's different to standard belt that we would possibly normally use, but this is been spec'd by the customer as puncture-proof because they don't want the titanium to puncture the belt and damage the belt. I don't know the full technicalities of it because we've never had it before, but from what I gather, all these different layers of textile braid inside stop it from being penetrated by something sharp. So these are the belts being delivered now. I'm assuming, I don't know whether these are the small ones or the big ones, but there's 2 belts here. I'm assuming they're going to be the big ones, to be honest. I'm just a little bit confused why we've got the wood in between there, but I'm sure it's just concertinaed on, I think. So these, I think, are the 2 big belts, and then there's the smaller belts coming to us tomorrow. Now, in a total curveball, on these conveyors, customer rang up start of this week saying that they've been let down by another supplier. They were having a vibrating feeder. One of these big conveyors was going to feed onto a vibrating feeder that then took the material onto another screen. That supplier has let them down and can't deliver in the timescale. So they rung us up the start of this week and said, could you possibly make us another conveyor? So if you remember a few episodes ago, I was at the oil company in Birmingham and they'd got some additions that they wanted us to look at. Well, this company is no different. This is usually what happens. You do a job for a company and then halfway through the job itself, can you do this for us? You know, is this possible? So start of this week, we had a conversation, got the spec done. Today's Wednesday, so we spoke to them on Monday. We got a quotation over to them yesterday. They come straight back with a purchase order. Yes, please, crack on. But what it has meant is the installation on these 4 conveyors is now delayed until the end of September because they're going to get the 5th conveyor off of us. These 4 conveyors here are still going to be made up and shipped in the next few weeks, but the actual installation of all five conveyors now we're doing for this company has now been postponed until the end of September, and that's when the 5th conveyor will get picked up. So everything will get installed towards the end of September in France, and it's all been delayed until then. So we've got these 4 conveyors They're having the belts fitted Monday, and then they will go, I think, which is the following week, so in 2 weeks' time. And then the 5th conveyor will go towards the end of September, and installation will follow after that. So, life's full of surprises. Our customers do keep us on our toes, and we do try to always say yes. And now we've got the battle of fitting it into the schedule, but I'm sure we'll do it, not a problem. And it's how life goes. So we've got that box in now, just making sure all the holes line up, which they do. Tank does need to sit central in the frame, which it looks as though it does, so we've got the measurements right there. We're just now going to put the box on top, and then we'll just make sure everything lines up after that. So that's it down sat on its mounts. We'll just have a check round now. Looks good on the tank. Nice and central in there. Just make sure we've got nothing catching anywhere. Because when this actually is in operation, it doesn't actually move that far. Most of the movement is actually on start up and switch off. It does actually shake quite a bit. But no, I think that's all right, to be honest. Yeah, all looks good. Anybody wondering why this tank's got to be lifted in from the top? The story behind that is this tank was actually designed originally with a flat bottom. And that's why this beam at the bottom here was put where it was, because that tank, if it had a flat bottom, would just slide in from the side. A couple of weeks ago, the customer said, could we change the bottom of these tanks so it creates a low point in the tank, because there's going to be an elbow and a flange welded to the bottom of that for the oil to come out of it. So we've changed that at the customer's request after we'd made the frame. So originally this tank was designed to slide in from the side, but now it's got to be lowered in from the top, which is no big deal really, but it just makes life a little bit more challenging just to lower it in from the top. But it does fit in from the top, so it's not a problem. So I've just been to the oil people up at Birmingham, and there's a kerfuffle. There's been a bit of miscommunication, probably on my part in fairness. If you remember the yellow walkway that we've had cut, and was actually cut wrong by our suppliers, well, the yellow walkway continues to cause more problems. The company's colours are yellow, white and black, I think. So they've had their floor painted inside their warehouse, their production facility. They've had that painted yellow, and I mean yellow. It's a good yellow. And there's a concern that our yellow steps and walkway will clash with their existing yellow floor. So I've just brought up a sample of the step to offer up against the floor just to see what it looks like, and I've left it with them on site. They're going to have a chat about it and come back to us, but there is a chance that we may have to paint that walkway and steps to a different colour just so it doesn't clash. So we'll see how that one pans out. If we have to paint it, it is what it is. It's not the end of the world. It's not ideal, but it's not the end of the world. We can soon do that. That's not a problem. So whilst I'm up in Birmingham, I have arranged to go and see Harry at Taroni Metals. Now, if you've been watching in the last few episodes and seen our social media, Harry Taroni is after a mobile picking line, or a picking line of some sorts, for his scrap metal operation up here in Birmingham. So I'm just on my way to go and see him now and have a chat with him and see what he's after and see if we can do something for him. So let's go and have a look.
So this is the area in Harry's yard where we're looking at positioning the picking line along this back wall here. Now at the minute they've got these skips that have got all different grades of material in. You can see there's copper wire in that one there, shiny copper wire. So we've got a little bit of space to deal with here. But what they actually got in the far corner over there, they've got a guillotine for separating. You might have brass and copper mixed together. So we want to utilise that machine on the picking line to separate the two materials. So we'll see what we can come up with for him anyway.
So I've just been up to see Harry. As you'll see, just did a little video of their setup there. They've got that row of skips, and what Harry's got in mind is a picking line, because he has a lot of mixed waste coming in, different coppers, different brasses, that sort of thing. And what he's looking at doing is there a way he can make his operation more efficient? Which a lot of the machinery that we build at Spitfire is all about making other companies' businesses more efficient. That's why we do what we do, because if people buy a machine from us, it may eliminate time or labour, or just make it easier, to be honest. So what Harry's looking at doing is looking at automating his process, which is currently a manual process. He's currently got guys physically separating the metals in the different bins. He's on about having a picking line, so he can tip all the mixed material on at the start of the picking line, and then his guys separate the material as it's coming through. The mobile picking line is not going to be the solution for Harry up there, purely because he's got the roof height issues up there. I don't know if you caught that on the video, but he's got a fairly low roof, so it won't work. So we're looking at doing a separate picking line. We spoke to him about the spec that he wants, different bits and bobs. So what we'll do now, we'll go back to the office, do a proposal for him, probably a basic CAD drawing, just to highlight what we're actually looking at proposing, and do a proposal, put a budgetary price against it, and then we'll send that over to Harry and see what he thinks. This is an idea at the minute for Taroni Metals. This isn't something they've currently got in place, they're looking at replacing. This is just an idea that they've got to see if they can just make the job more efficient. So this isn't a dead cert, this is what's going to happen. At the minute, this is just a conversation that we're just having with them. What could we do to help them? What would it look like? What would it cost? All that sort of thing. And then from there, they can decide if that's what they want to do. It might be too much money for them. It might be within their budget. It might not achieve what they want to achieve, or it might make it really efficient for them. And that's their decision to make. So, like I say, we'll go do a proposal, put a price against it, and then just see what happens. Good morning. It's Friday, and this weekend is demolition weekend. Now, previously, I've said that we're going to make some space in the workshop, and we're going to get rid of the mezzanine. This here behind me, this is going this weekend to free up fabrication space. Now, this mezzanine has been used to store all the stuff that we don't really need over the years. Whenever there's something left from a job, it's always been tucked away up there, and it's just a waste of space. And now we're taking on the new unit next door, which I'll show you in a future episode, because it's not actually ours yet, but we're just going to use it for storage at this moment in time. Everything that's on the mezzanine is currently being put in there for temporary storage until it gets its new roof put on. So we're going to empty this mezzanine, and we're going to rip this mezzanine down. Now, let me just flip the camera around, and I'll give you a little bit of a brief history of why we've got the mezzanine and where it all come from. So originally, when we first come to this farm, where we're based now, we had that unit over there. It was 1,200 square foot and served us well, to be honest, to start with, but we outgrew that, and across the other side of the yard, this unit became available. So let me just go in here and I'll tell you, because there was a partition wall in here. Just come past these conveyors. So originally there was a partition wall in here, and it came to the right of that doorway just there. So the partition wall, when we first moved in here, was here.
and we had this as our workshop, which when you think how much we've got now is tiny. And when we first had this, we needed some storage, so we put this mezzanine floor up about 12 years ago, 12, 13 years ago now. And we use it for the machine shop underneath. So Colin's on the lathe now, and we've got the mill in there, and we've got all the racking for all the tooling and everything. And then next door to it, this originally was our paint booth. But when we took on the paint booth where we are now, we ended up converting this into a tea room. So the plan is this weekend, we're clearing the floor down now. So we're clearing all the stuff off the top, and we're going to rip that down. The demolition dream team for this weekend is Archie, who is our guest appearance. I think he's actually on, you're on next week's episode, guest appearance next week, aren't you, with the belt fitters? The belt fitters next week are in on Monday, and you're going to do a walk around next week of the belt fitting, so you can see how the belt fitting works. We've also got JMO, who did the walk around of the place where they were recycling the catalytic converters the other day. So we've got JMO on the dream team this weekend, and we've also got my youngest son George, with his big hair. We've drafted him in this weekend. He's going to come in and give us a hand to take this down. So we're going to tidy some stuff away, and then we're going to have to start moving this lathe and the mill and these other bits under here. But Colin, who runs the lathe, he's here till lunchtime. It's now mid-late morning. He's here for another few hours, and he's running the lathe. So we're going to have to work around him when he's gone at lunchtime. We'll crack on and get the lathe moved, the mill moved, and all the racking that's got all the tooling and everything on it. So I'm going to see if I've got some magic fingers. Oh, magic fingers aren't working. Let's do the magic hand. So that is the lathe and the mill moved. We've moved the lathe and the mill into the back of the small fab workshop just temporarily, because until we get the new unit proper next door, that will be our stores, and what is currently our stores will be the machine shop, and it will give us space to probably get some more machine tools. So it's interesting when you do a job like this, because you find the stuff that you've been looking for years, some of it, couldn't find it. And also you have a chance to bin the stuff that you're probably going to need for the next 6 months. So this is the mezzanine cleared off. The last time this looked as empty as this was 12 or 13 years ago when we first put it up. Can't actually remember when it was, but it was about 12 or 13 years ago. Now this is the view from up here of our main workshop. And this will probably be one of the last times we'll see this view from up here. Now at one point there was a conversation about actually putting the offices up here, actually building offices on this mezzanine. And that was going to be my office just there in the corner with some nice windows, so I could spy on everybody whilst they were working. But we've soon moved past that and ended up with the offices we have, which I'm glad we did, because we would have easily outgrown this area up here, and now it would be make this decision more difficult, because we do desperately need this space here for fabrication space. So what we were going to do was to remove this mezzanine and have this end here, where this mezzanine sits, this end of the workshop, as our final assembly area. But actually thinking about it, it makes more sense, because through this wall here, that's metal cutting in there. So logically, material comes in, gets metal cut in there, will come around the workshop in this door here, and then the components get fabricated. And then when it's finished being fabricated, it can go out that end door there, or it can go around the outside at the minute. The new roof we would like to put up is actually outside there. So that eventually may become final assembly. But at the minute we can fabricate this end, go out that door down the far end of the workshop. The paint booth is left out that door. Components can get painted out there
be stored in the backyard and then brought in that end of the workshop for final assembly, and then go out into the backyard when the projects are completed, which makes a lot more sense than actually having the assembly area this end of the workshop, which is what we originally thought. So it gives us a lot more flow through the workshop, because the alternative was, if this was final assembly this end, painted components would have to come all the way around the outside, and we do use that area for storage at the minute, as you've probably seen in previous videos. Or the other alternative is around all the way around the other side, and the yard around there is not very good, and I could just see stuff falling off forklifts and everything. So this makes a lot more sense. So that's it for clearing this off. It's now time to take the mezzanine down. So on the basis that Sunday is double time and time is money, we need to crack on with this job. So we'll just use the forklift to rip this wall down. This was the tea room, not anymore. This is going. And that is where we've got to today. We didn't do the handrail, as I said a minute ago. We thought we'd smash this wall out. Let's taking this out. It's quite good fun. We use the forklift. So we've took that out now. That's cleared all the walls under here. And that's it for today. So back in the morning, got to disconnect. There's a compressor up on this floor, the original workshop compressor. We have got two compressors. There's a screw compressor in the corner of the small fab workshop that does the paint and the cutover, and then we have another compressor in here. And it's rigged into there's a ring main in the workshop in here that the fabricator's using here. So I've got to disconnect that in the morning on this black cable here, pull that out, pull the compressor down, and then that's it. We can start having the handrails off here. Start lifting the floors and start taking the framework down. So with a bit of luck, this job might be done tomorrow. It just depends how tricky it is to take out, because I do know that these floor joists here were screwed in, I think. So that might be handy if they were screwed in rather than nailed. Might come out relatively easy. Let's see what happens tomorrow. So these conveyors, the 4 conveyors going to France, are ready for the belts. And I bet I thought I'd just give a walk round and show you what we've done to these since we last spoke, just to give you an idea what we need to do to make sure they're ready for having the belts fitted. So let me just spin this round and I'll show you what we've been doing. So the head and tail drums have now been fitted. Now on the tail drums here, obviously when the belt's fitted, you've got to tension the belt. So this threaded rod here is what we use to tension the belt. We also use it for tracking the belt. You can't just stick a belt on and expect it to run true and in line. You have to track the belt, and we'll cover that in the next episode once the belts are fitted. Now, one other thing that we do a number of things before we have the belts fitted. We've actually had it so that this distance here between the back plate and here is in the right place for when the belt is tightened. Now, we set that because once upon a time we left that loose down here, thinking the belt fitters would fit the belt and tension it up to where it is there, but they didn't. They fitted the belt and tensioned it so it was there, and because of the top plate at the top, if you can see up there, the top plate comes in, you actually end up, that top plate there is there to keep the material on the belt. Up there. And obviously we need the belt to go underneath that plate so the material falls off the plate onto the belt. And what happened in the past is, because that drum was down here, there was a gap between the back of the drum and that plate. So we put it in the position we want it in when it's tensioned. the belt fitters can take a measurement in that position, and then they will slacken that off to give them some slack to do the belt joint, and then tension it back up. So we make sure that that's in the right position. We've now got all the rollers fitted coming down here and up the other side, and we also put this rope in here so that the belt fitters know where the belt's got to run, because we've also had that before where the belt has been fitted the wrong side of a roller, and we had to get the roller out and fit it the right side of the belt, which meant that the belt was then needed tensioning different and caused no end of problems. So we do different things because we've had problems in the past. As you can imagine, the belt runs on these top rollers, comes underneath, comes over a roller just there, over a roller there, over a roller there, but this one here, we want the belt to run underneath this one, so you can see the rope runs underneath that roller. Because if it ran over the top of that, the belt would want to come up and cut the corner off. So that roller is there to hold the belt down. So we've got a returns roller in there, which is on discs, same as this one here. So we've got these discs on here on this returns roller, and that's because the belt's going to be sat on top of that, and because of the profile of the belt with the flexible sidewall and the cleats in the middle, that's why we use a disc on that one, and I'll show you that once it's fitted. It'll make more sense once it's fitted. But actually the smooth side of the belt is going to be running on this roller here, so that's why that one is smooth, and that's why that one's got discs and all the other ones have got discs. The feet have been fitted now, so we've got 3 adjustable feet on here, and once it's got its normal legs on, its working legs, these are just transport legs. Once it's got normal legs on, there'll also be adjustable feet at the end, at the bottom of them. So once we get to site, we can actually adjust everything and level it all up, because we do need the conveyor to run level. If the conveyor is twisted, the belt will not run true and it will just cause us problems. So we have adjustable feet so we can adjust it so it all works nicely. Gearboxes have been fitted. So on this conveyor, it's a fairly slow conveyor on these. 2.2 kilowatt motors and gearboxes on this, 1.5 on the smaller ones. I've got a belt calculator that I did myself on an Excel spreadsheet, and the customer, when they ordered these conveyors, they said to us what sort of tonnage they wanted to move in an hour, and they also gave us the cubic density of that material, so they told us how much 1 cubic metre of material weighed, and from that we worked out the width and speed of the conveyor and also the depth of material on the conveyor to work out what their output requirement was. And I think one of them was 10 cubic metres an hour, and actually we've spec'd this to be, I think it was about 21 cubic metres an hour. So we know we've got plenty of capacity. You'd rather have a conveyor running only half full but constantly and be man on the job. Can you still say that these days? I don't really know, to be honest. But anyway, you want to make sure that it's man on the job anyway, rather than struggling for capacity and the customer on the phone saying we just can't get enough material up this belt. So that was all worked out by us. They gave us that information, we worked that out. And on both conveyors, one conveyor is got the gearbox on this side, and on the other one the gearbox is on the other side, and that's because where these conveyors are going to situate in the rest of the plant, it suits to have the gearbox on either side like it is on that one, and these two are no different. So we've got the gearbox on one side here and on the other side just there, and these are in the same position as well. All the returns rollers fitted, all the top rollers fitted, head and tail drums fitted. Got a rope in this one so that we know where the belt goes. And then Once the belt is fitted next week, we'll just go through what it looks like at that point. And then the side skirts will be fitted. If you remember in the previous episode, when we did the dry fit, we made the side skirts. So the belt will now get fitted on here. Side skirts will come over the sides, and this will all be enclosed, and all you'll see will be the centre part of the conveyor coming through, and then continue up here. And then once we've done that, there is some underguards to go on as well. So there'll be some guards that get fitted on the underside of the actual subframe itself, so that nobody can get their hands into any returns rollers or anything like that. And it's full guarding for all the way from the top all the way down to the floor at the bottom. So the belt process is a specialist process. They're coming in next week, as I say. We're going to try and video the process as much as possible. I've got to go to Scotland for the day on Monday, so I've got a long day on Monday. But Archie will be here. He's got the spare DJI, and he's going to try and capture the whole process from start to finish, because it is quite an interesting process. It's actually a hot vulcanised joint that they're doing, so and that's quite an interesting process. So we're going to try and get that, and that will come up in the next episode. So that's where we are with these conveyors now. Next stage is fitting the belts. We'll catch that up in the next episode, and you can see how it's all done.
So this is it with the mezzanine gone. Look how much space we've created by getting rid of the mezzanine. This is going to make a big difference in the workshop for the lads. Now that bit of ducting there, that's still got to come out. That was part of the old extraction system in the paint booth. But apart from that, we are pretty much there. Me and Archie are going to come in tomorrow to lay it out. We're going to move those racks there somewhere else, because that's not ideal being there. So we're going to change things about and get it all sorted. The compressor's got to go in that far corner. So me and Archie are coming in tomorrow just to lay it all out, so we're all ready for Monday.
So that's it for this episode. Thank you for watching. Thank you for all the ones that have subscribed. Thank you for the messages. There's a certain viewer that I saw at Hillhead that left a really nice comment the other day. Thank you to you. You know who you are, and I hope you're doing well at this moment. So we'll see you on the next episode. Let's get Rob on it.
Oh no.
Now last week, Rob told me that he was going to get a new tattoo, and he said he was going to have a claymore put on his neck. I asked him if that was wise, because when he said claymore, I thought the mine, the thing that sticks in the ground and shoots ball bearings out. He's actually had quite a tasteful tattoo, actually, and I actually quite like it. And I'm quite relieved he didn't have the big bomb thing on his neck. He's actually gone for, show it, he's gone for that.
Which is not a mine.
Which is not a mine.
It's not mine.
It's more of a sword claymore. So got it totally wrong, but I quite like it. That's quite cool. Well done, Rob.
Thanks.